Right, so most likely you just watched the last rational expressions video that dealt with how to simplify complex rational expressions but using division. In this case, we're going to figure out what the least common denominator is first and then deal with it from there. So here, the first thing I'm going to do is I'm going to um, rewrite the equation here, or not equation, but expression here, as a factored form. So I've got the 2 in the numerator. I'm going to factor the denominator, x plus 1, x minus 1. And then in my denominator, I've got 3 and divided by x plus 1. Okay, so if I look at the least common denominator, remember what we did in previous videos was we have to see, all right, so we have combined, they both contain an x plus 1. So that's a part that they already have in common. And then to get the least common, I have to take whatever factors they have that are unique to each other. So like x minus 1 is unique, so therefore that has to be introduced here as well for my least common denominator. That's an x. Look like a v for a minute. So now what I do is I multiply both numerator and denominator by x plus 1, x minus 1, and I'm going to say that that's over 1 just to make my life easier. And down here, x plus 1, x minus 1, all over 1, again, to make my life a little bit easier. So if I were to go through and multiply this out, what I'm basically doing is I am multiplying both numerator and denominator by whatever it is that the common denominator would be. So that way it just gets rid of the denominators within each fraction. So again, basically what I'm doing is I'm extending this to make this one big fraction. And here's a product in the numerator and here's a product in the denominator. So that means I've got, if I just look at it as I only look at the numerator at one time, then I see I've got a 2 in this numerator, I got an x plus 1 and x minus 1 in this numerator, and I got a 1 in the denominator. Here, I've got an x plus 1, x minus 1, and I got a 1 in the denominator. So now, this is in the denominator of a fraction. This is in the numerator of a fraction that I'm multiplying, which means then x plus 1 and x plus 1 go bye-bye. X minus 1 and x minus 1 go away. And then I look at my denominator, and I've got a fraction times a fraction. So when I have a fraction times a fraction, we end up where we eliminate the common factor. So if you look, what should happen is I should no longer have a complex fraction. I actually have my denominators for each are gone, which is the intent. That's why we went through and we multiplied both numerator and denominator by the least common denominator. All right, so now what we have is, rewrite this. I see that in my numerator I've just got a 2 over 1. Well, 2 over 1, that's just 2. And then in my denominator I've got a 3 and I've got an x minus 1, and that's all over 1. That's the only thing that's left. This is the exact same answer. I'm using the exact same problems that I used in the last video, the same exact ones, so that you can see and compare the process. So you may prefer using the LCD more than anything else, and that's fine, completely up to you. All right, or you might want to go through and do the division method for simplifying the complex rational expression. The next one, though, we still want to figure out the least common denominator. So let's go through and figure out the least common denominator for each of these. So if I look here, my common denominator in the first one is a 1. In the second one, it's an n plus 5. So my LCD in the numerator is going to be n plus 5. Then if I look at my denominator, because remember, I got to add and subtract these things first. So for me to be able to add and subtract these things first, I've got to figure out the common denominator. So my denominator's least common denominator is not only the x plus 5, but it's also, sorry, not x, but n, the n minus 5. So that means then total so that I can go through and I want to multiply the numerator and denominator by the exact same thing, because I can't just multiply the numerator by one thing and the denominator by a different thing, because then I lose that relationship they already had. So I need the least common denominator for both the numerator and denominator in this case, because we have so many fractions within fractions. Okay, so my least common denominator is now going to be the n plus 5, because that's what they have in common, and then whatever unique ones that each has. Well, this is the only one that's unique, so it's going to be n minus 5. All right, so then what do we do with this? It's going to look kind of crazy, so just bear with me. But I'm going to have to multiply both numerator and denominator by n plus 5 and n minus 5. And then what is that big numerator? Well, it's n divided by, I'm just going to use the 1 just so that we keep in context where everything is. And then 4n divided by n plus 5. Again, that's only the numerator of the entire fraction. Then we need to do the same thing with our denominator. So this looks like it's getting out of hand, but it's actually not as bad as you think. All right, so whenever we have something on the outside and we're multiplying, we distribute. Well, you have to do the same thing, but you have to consider this n plus 5, n minus 5 as what's being multiplied by each thing. And I'm going to do that for both of these, okay? But I'm going to show all the steps for it, okay? So when we take a look again, so equals, I'm going to take this n plus 5, n minus 5. So think of n plus 5 times n minus 5 being very similar to like 2 times 3. That will be something that then gets multiplied to each thing. But I don't want to multiply it all out because I'm hoping to get rid of some common factors that are going to show up. All right, so now if I look at this, I've got to deal with distributing this to the first thing, which if I multiply this by the first thing, I'm just going to have n times n plus 5, n minus 5. That's that whole first multiplying. My second is going to be minus 4n, n plus 5, n minus 5. And then in the denominator there is n plus 5. Again, we've only done the work through here. Now we have to deal with the denominator. So now when I go through and do this, I'm going to multiply this by 1. So I'm going to end up with n plus 5, n minus 5 divided by the n plus 5 plus, again, multiply this by whatever is in the numerator, n plus 5, n minus 5 divided by n minus 5. All right, we're hoping that we can eliminate some common factors by going through and setting this up. So here, there's no common factor, numerator, denominator. But here, you can see that we have an n plus 5 and an n plus 5, which then means I no longer have a denominator in the numerator. Down here, I've got an n plus 5 and an n plus 5. Here, I've got an n minus 5 and an n minus 5. So now I no longer have a denominator in the denominator. All right, so now that we've run out of room on this part, let's go ahead and move ourselves up here. All right, and you got to be very careful not to make small mistakes here and there. So let's write what we have left so that we don't make any small mistake. So in my numerator, I'm left with the n times the n plus 5 times the n minus 5 minus 4 times n and n minus 5. And we'll deal with all of that momentarily. All right, we'll clean that up and then we'll work from there. Now, if I look at the denominator, you got to be very careful here. I've got an n minus 5 here plus an n plus 5 here. So I've got an n minus 5 plus n plus 5. So what we want to do is try to simplify everything now. One thing that we've done a lot of is factor by grouping, and we look for a common factor that we can take out. So one of the things that I want to point out is if I look here, and I'm just going to underline it, I've got an n here, I've got an n here, I've got an n minus 5, and I've got an n minus 5. So those are common factors that I want to actually factor out of each term. Right? We've done this before. If I had a 4x squared and an x, so 4x squared plus x, I would factor that x out. Well, here, this is one big term, this is one big term. So I'm going to factor out what they have in common. All right, so this is a little wonky from what we usually do, but we're still doing the exact same thing that we've been trained. So I'm going to factor out an n, and I'm going to factor out the n minus 5. And then remember, what goes into parentheses is whatever is left. So whatever is left, whatever I do not have a line under, I've got n plus 5 minus 4. So I'm going to write n plus 5 and then minus 4. Now let's take a look at our denominator. I have an n plus n, so that's going to give me 2n. I have a positive 5. Sorry, I try that again. I have a negative 5 and a positive 5. So those will add out to give me 0. So that means the only thing I have left in the denominator is 2n. Now I got to simplify that numerator though, because I've still got other work that has to be done here. So that means I have an n minus 5, and then we clean this up. So I have an n plus 5 minus 4. So that's going to give me an n plus 1. All of that is divided by 2n. All right, so now looking at what's here, I notice that I have an n here in the numerator and I have an n here in the denominator, so those will divide out. And then the only thing that I have left, sorry for the bell noise, is I have an n minus 5, n plus 1, all of which is divided by 2. Now remember, I said I did the exact same problems that we did in the previous video. So if we did them correctly, you would notice that they have the exact same answers at the end for both of these. So now it's entirely up to you which version of or which method for simplifying complex rational expressions you decide. It might depend upon what the problem entails. If this looks way too much for you, then you would go to the other version that we were using, which was just basically by using division. But something like this, it might be better to go through and just use the least common denominator, because I don't have addition and subtraction within the fraction. It might be better just to go ahead and use the least common denominator, multiply both numerator and denominator by it to make that part divide out. All right, so hopefully this was helpful, useful, and allays any fears of going through and doing this. If you have some difficulties still, my suggestion is to rewind, play through, but definitely listen to what is said as we're going through the problems. That is pretty much where the guidance comes from. Okay. All right. Have a great rest of your day, and hopefully this was helpful.